Fingers crossed. Hey, it turns. Fingers crossed the video comes up. Last time I did this, when it went live onto YouTube, it then just went black. So it's about a 30-second delay. It should come onto my laptop any second. So today, guys, we're going to be looking at ionic formula part 2. Still hasn't come up on the YouTube. Oh, and it's live. Amazing. So I'll close that down now. I've popped out the chat window though, but I am live and it seems to be functioning. Can you guys hear me okay? Is the quality of sound all right? I hope so. Do let me know in the chat if I need to work on that. Okay, so let's share screen. Let's share the screen and then get rid of my camera entirely. I'm going to risk it, guys. I'm going to risk it for a biscuit. What I'm going to do is I'm going to stop the camera and risk it for a biscuit. You guys always seem to be the ones that suffer with this particular part of the lesson. Every time I have you guys, I turn off the camera and it crashes. Here we go. We are in. Okay, guys, so I set you, this is actually the lesson for today. But before I do that, I'm going to run through your ionic formula homework. So we did ionic reactions and formulae. So, okay, I'm just going to quickly go through these questions. They're all exam-based questions, as you can see. I was going to put the year that I took them off the papers, actually. There we go. Okay. So I've got my pen. It's going to let me write on it. I'll then try and remember to save this as the mark scheme rather than the questions. Oh, I might do that. If I do that, it should then let me say save as. And I'm going to save it as the mark scheme. It won't. That way, at least I won't forget. Save. There we go. So that's now the mark scheme. Cool. So sodium. 2-mark question. Sodium fluoride is an ionic compound. Describe how sodium atoms and fluorine atoms interact to form a sodium ion and a fluorine ion. So you can get all the marks here from doing a diagram. Only have to show the outermost electrons. Remember to do, sorry, I didn't follow my usual routine there. There we go. And the outcome would be Na+. The outer shell has now completely gone and becomes fully positive. And F- has now got 7 circles and 1 cross. Now you could have done them as dots or crosses. So that's the 2 marks there, guys. That's the 2 marks in its entirety. You would get both marks for that particular diagram. But the marks in a written form would be saying that sodium loses 1 electron, and you have to say the number 1, loses 1 electron to fluorine. I'd quite like to put atom in there. Sodium atom loses 1 electron to a fluorine atom, forming, second bullet point, so sodium, so Na, sodium becomes Na+, so sodium becomes Na+, and fluorine becomes fluoride, becomes F-1-. Those are the options in terms of how you want to do it. So 2 marks for those 2. Loses 1 electron to fluorine. So yeah, so fluorine's gaining 1 electron. You could have said the vice versa. You could have said the vice versa on that if you'd liked. You know, if you'd said fluorine gains 1 electron from the sodium, that would be totally fine as well. All good. Okay, next one. So next one, it says lithium fluoride. I really wish I could anyway. Lithium fluoride LAF ionic compound contains lithium cations, fluoride anions. It's given you the configuration of the atoms, and it then says complete the figure for the ions. Oh, that's quite clever. So charge is +1 for the lithium, and all I have to do is put a bracket and add the charge. Yeah, you could put 1+ or +1. It makes no difference. You can even just put plus in this particular scenario. Fluorine requires a bit more effort. Yeah, because it's now become a fluoride ion. Remember, the non-metals change their names, and the charge is 1-, and there's your final answer. Since the charges are on here, since the charges are on those little shelves, if you hadn't put them there and there, they wouldn't actually care. But the square brackets is needed because square brackets literally translates to I'm an ion. Yeah, and it's 4 marks. And the 4 marks come from 1 for the square brackets on the lithium, and then 1 for its charge, and then 1 for the square brackets and the electrons being correct. And that, so those 2 there are 1 mark. If you forget the bracket, you lose it. If you forget the dots and crosses, you lose it. So just bear that in mind. Yeah, so that's 2 marks. So those 2 there are 1 mark. Next. Okay, so magnesium has an electronic configuration of 282. Okay. Next, oxygen has an electronic configuration of 2,6. Explain in terms of electronic configuration how magnesium and oxygen atoms react to form the ionic compound of magnesium oxide, and include a description of the structure of solid magnesium oxide. Okay, guys, I'm very sorry. We haven't done the structure yet, so you can ignore mark 6. So it's only actually out of 5 in reality. I apologize for that. I didn't manage to screen it well enough. So you can ignore that one. Okay, but let's run through it. So we're going to say magnesium loses 2 electrons. So I keep doing that. A magnesium atom, I'll be good. I'll be really good. A magnesium, if I was in an exam, this is what I would do. So it's only reasonable that I do such. A magnesium atom loses 2. I'm actually going to write down, rather than my short little E-, I'm going to be good, as if I'm in an exam. A magnesium atom loses 2 electrons, 1 mark. An oxygen atom, the oxygen atom gains 2 electrons from magnesium. I don't think they'd really care if you didn't act. I think it's implied, even if you didn't say from the magnesium. If one's losing, the other one's gaining, it's kind of implied, but that's another mark. Next, now we need to talk about their configurations. So the magnesium, so bullet point number 1, bullet point number 2, bullet point number 3. So magnesium, okay, I'm going to be good, as if I'm in an exam. Magnesium starts 282 and becomes 28 in square brackets plus 2. That's the mark. It's that one. Yeah. Could we use the diagram? Yes, probably. I don't see why not. In fact, I definitely think the diagram would be very reasonable here. They'd say accept the diagram. Yeah, and then I'm going to say it's nice, Julius, absolutely, I think you can, but you'd have to draw the reaction and the product. You'd have to do exactly the same thing as I did there. Yeah, if you did that, can I just point out, you will lose because they gave you this, Julian, because they gave you the numbers. That's the bit you're going to lose your marks on, because it's a bit mean, because if your diagram is correctly drawn, then it's totally reasonable that you get the 282. Yeah, you can have it, Julius. Definitely. Today you can, for sure. Oxygen starts 2,6 and becomes oxide. It's nice to do that. 2,8. Ooh, 2-, which is now an oxide ion, which is nice. There you go. O2- oxide. There you go. An oxide ion. Anion, if you like. So there's your next mark, is the 28. Yeah, I think that actually gives you the 4 marks. So it was out of 6, but actually it was out of 4. Those are your 4 marks. Because the next 2 marks are now for the description of the structure, to say it's a giant ionic lattice held together by the strong electrostatic attraction. 2 marks for that one. So at that point, those are your marks. If you had done a diagram, you know, we could zoom in and do a miniature version of this, if it lets me. Struggling. Oh, Julius, if you did a diagram, you'd have to show all the electrons. You'd have to show all of them, not just the outermost. Yeah. If you were going to do it, in a diagram, you'd have to show, because you'd have to get the 282 from it. Yeah, you'd have to show that. Then the oxygen, 286, northeast, southwest, northeast, and then, yeah, so that'll get you 2 of the marks, because magnesium's losing 2 and oxygen is gaining 2. That gets you 2 of the marks, tick, tick. Then the final one is, you would have to do this as well to get this mark. So just so you know, by the way, yeah, I'm sorry, I should try and keep them the same size. Yeah, Mg, 2 electrons. You'd have to show all the shells. You'd have to show them because it's getting you the 28. Yeah, this one was 282. This one was 26. And then in order to get this, you'd have to say 28 in square brackets, 2 plus. So yes, you can get all the marks from the diagram. It can be done. Yeah, magnesium shrinks, whereas oxygen grows. Yeah, and then you have to show these guys as crosses, and then it gains the 2 minus, and then it's 2,8, same thing, 2 minus and 2 plus. Yes, so you can, Julius. Cool, I did, well done. Great job for showing all your shells. Yeah, okay, next. Okay, sodium chloride is an ionic compound containing sodium ions, chloride ions, shown in the diagram, yada, yada, yada. Explain how. It's going to be interesting here. 6 marks again. And look, it's done it again. These are all Edexcel paper questions, you see, so I haven't edited them, and I should have because we haven't covered it in lesson yet. Explain how the atoms form the ions. Yeah, done. And how the ions are arranged in the solid. So you can't do the latter half. Yeah, that's irritating. So we're down to 4 marks again. Okay, so this time, let's do diagram. Now, notice they gave us the config, so we have to draw all the electrons. So sodium, 2, 7. You notice I've switched them for crosses this time because it doesn't matter. As long as the other person, there we go. And then chlorine even. So chlorine, 2,8, 7. Yeah. 2,8,7, right, there we go. And then product, Na, circle, circle, square brackets. All electrons must be shown because they want the configuration. Yeah, this diagram would get you all the marks. That's 1 plus because it's lost only 1 electron. Yeah, so 1 plus. And then the chloride, which it's now known as. Yeah, so this one had... Try and speed up my diagram here because I can certainly do it a little bit quicker. And then cross, square brackets, 1 minus. Arrangements, something like that. Get rid of that one and that one, put it back on. And put that charge outside. And this is 2,8 square brackets plus 1. And this is 2,8 square. No, that's not chloride. 2,8,8 square brackets 1 minus. There you go. I like it. If you're going to, yeah. Oh, you may wish to use a diagram in your answer. Winner. Love it. Yeah, you gain all the marks for that, folks. If you want it in words, yeah, sodium loses 1 electron to chlorine. Oh, nice one. To Cl. Cl gains 1 electron. Gains 1 electron from sodium. 2,8 square brackets plus 1 for Na plus. And then Cl minus being 2,8 square brackets minus. There you go. 1 plus 1 minus. There we go. Done. Like it. Okay, next. Give the electronic configurations. This is a different paper, of course, which kind of makes sense. So sodium is going to become 2,8 square brackets. I wonder how many people forgot their square brackets. You don't need the 1 if you don't want to, by the way. You can just have plus in charges. And then the chloride is 2,8,8 square bracket, 1 minus. I prefer putting in the numbers, though. I always think it's better. Do you have to mention that the oxygen becomes bigger? No, you don't, Masaru. That's actually the first part of A-level that I always started teaching that early. It's nice to mention this idea that atoms do change size when they become ions. So whenever you lose electrons, you shrink. Whenever you gain electrons, you get bigger, you swell. And that actually is not a GCSE necessity. It's actually an A-level one. So it's just, I'm dropping that in without even you guys realizing. Except now I've told you, so I shouldn't have done that. Oh. Okay, explain how in this reaction, magnesium and oxygen atoms form a solid with a high melting point. Okay, now, by the way, you can score the marks on. Yeah, we can score the marks on this. So we're going to say magnesium loses 2 electrons to oxygen. Remember that we'd have to write this down properly in words, guys. I'm just very aware that I'm cheating here with symbols and everything. Yeah, in your exam, you'd have to write it out as a full sentence. Please be aware of this. Magnesium loses 2 electrons to oxygen. Oxygen gains 2 electrons from magnesium. Yeah, magnesium becomes Mg2+. Oxygen becomes O2-. And it's nice to give the configurations. Magnesium will become 2,8 square brackets 2+. Oxygen, which was 2,6 originally, becomes 2,8. They become the same. They become what's called isoelectronic. Yeah, iso means the same in chemistry. These are isoelectronic. They're the same. This iso in chemistry means same. Same electron config. It's kind of cool that, just with different charges. The last thing is we can now give the high melting point bit. Oh, right. So now we need to say Mg2+ attracts O2-. 1 mark. Yeah, they attract each other. Opposite charges attract. Last mark with the strong, notice my capitalization, strong electrostatic attraction. Lots of energy, high melting point. Lots of energy to break. High melting point. High MPT. There we go. The marks, 1, 1, 1, 1, 1, and actually just up to the electrostatic attraction. That they will allow that at that point. But it's nice to give that extra level of detail. Okay, next. Sodium has the atomic number. Which line correctly shows the protons, neutrons, positive charge on a sodium ion? Right, atomic number 11. So we find that on our table, 11 and 23. Yeah. So it's got 11 protons, so it's either C or D. Those two are correct. Numbers of neutrons is 23 minus 11, which is 12. So it's now D, and then that makes sense because it's positive, so it's going to have 1 less electron. So the answer was D. 1 mark. Moving on. An aluminium atom has this. Which one shows the rover? An aluminium ion. Okay, so we know that it's still going to have 13 protons. So it's that one and that one are correct. It's going to have, number 27, it's going to have 14. So 27 minus 13 is 14 neutrons. Oh, that one and that one is correct. But now it's a +3 ion. Yeah, +3 ion. It's lost 3 electrons. So it's only going to have 10 of them. So the answer was B. Bit more tricky than the other one. Bit more tricky. Next, 1 mark. Next, complete the table for relative masses. Oh, always nice to remind ourselves. Relative mass of a proton is 1. Relative mass of an electron is negligible. Or 1/1836, if you prefer. Relative charge, 0 minus 1 for the electron. Position in the atom, nucleus. I'll put in nucleus as well, since they've done it. And I'll put in energy levels. Yeah, in energy levels. Like it. That's clever, isn't it? Next, complete the sentence. Put a cross in the... okay. An atom of an element always contains more protons than neutrons. No, that's not true. An equal number of protons and neutrons. No, that's not true, by the way. More protons than neutrons. No. Why? Well, we can give an example. Carbon 6 carbon 6 and 12. That has the same number. Yeah, so that doesn't fit it. And then it says always has an equal number. That's not true either. Lithium is 3 and 7. That's uneven because this has 6 protons and 6 neutrons. So this one now has 3 protons and 4 neutrons. That's also garbage. More electrons than protons? No, an atom has always got the same number. Yeah, an atom, that's the key thing there. An ion always has an awkward number, but it wouldn't be more electrons. It could be more or less electrons. Yeah, equal number of protons. That is correct for our atom. So that one there is, yeah, it's correct. Next, use the boxes. Okay, from the box, choose a symbol of an atom in group 2 of the periodic table. Group 2, calcium. Yeah. By the way, notice that the question says choose the symbol. Lots of students often write their answers in words and they'll lose the mark. An atom that readily forms an ion of a 2- OO, because oxygen always forms a 2- ion. The formula of magnesium of aluminium nitrate is this. State the total number of atoms in it. Okay, that's more interesting. I've got 1 aluminium. It's not ideal doing this on a Word document, by the way. It's the problem I've got, you see. There we go. I have 1 aluminium atom. Clever trick. I've got 3 nitrogen atoms. And I have 9. Total number 13. Tick it if you got it. Last one. What is the most likely formula of aluminium nitride? Like we did this last lesson. Find aluminium on the periodic table. It's in group 3. Aluminium plus 3. I'm just going to quickly show you this on the table again because we're doing it today, of course. GCSE table. There we go. So aluminium, group 3 plus 3. Let's just write the numbers across the top since I think it's always beneficial to do it. I hate this thing sometimes. I just want them to give me what I act like. Anyway, plus 1, plus 2, plus 3, nothing, minus 3, minus 2, minus 1, nothing. I like it. So aluminium plus 3, nitrogen 3 minus. It's Alan. Here's my answer. It's just Alan. N3 minus. It cancels. It's Alan. I'm done. It's D. Right. The total marks then, that's a tad awkward. Because we need to add up the scores for our check sheet. Oh, no. Okay. Let's add up the scores. So 2 marks, 4 marks, 4 marks, and then, and then 4 marks, then 6 marks. No, it wasn't 6, it was 4. That was the key thing there, was also 4 marks. 2 marks there, and then that one you could get all 6 on. So 2, 6, 10, 14, 14, 22 so far, 22, 23, 24, 24, 25, 26, 27, 28, 28, 29, 30, 31, 32. So it was out of 32. Score sheet. I may have already written it in. It is possible. Possiblement. Let's have a look. There we go. Ionic formulae. People are missing. So ionic reactions and ions. I think that's a reasonable thing to do. Do wrap text. Shrink it if I can. Make a little bit larger. There we go. Right, it was out of 32. Be nice to see people putting in their numbers. That would be grand, guys. Out of 32. Haven't got anyone. Oh, hey, there you go. I think it's Lauren, the first person in. Lauren, well done. First person in. Great job. How did you get on? Gayatri, Jack, and Henry, you're missing from the previous homework. Be nice to see you putting those in, guys. It wasn't actually a homework. That was one of the ones that was the homework that you did, or the work you did in one of my cover lessons. Right. I kind of want to wait there while you guys do that. Right, okay, guys, today's lesson. Let's crack on. Okay, so create simple ionic formulas, and I thought I'd do some naming today as well. So the first thing I want to do in today's lesson, so there's my learning objectives. The title is Ionic Formula Part 2. So I just want to do a quick review with you guys, watching me do a couple of exercises here. And then we're going to go into complex ions as well. I'll leave the learning objectives like that. Okay, so today's lesson. So first of all, I want to do a bit of naming. We haven't done an awful lot of naming over, and it's nice just to, where is the link for the score sheet from Jack? Oh, can someone give Jack the score sheet link? I don't have a huge amount of time left on my lesson, and I don't want to spend ages doing it. Copy. Paste. Send. Oh, that's irritating. I don't have an enter button. There we go. Score sheet. Oops. Nope. Go back to here. Cool. Okay. So magnesium oxide. Let's build it. So what I figured we'd do is we could do cation, anion, and then formula. Yeah. So we can go magnesium. We can find its sign on the periodic table. Magnesium's in group 2, so it's +2. Yeah, so cation is the positive ion, Mg2+. Anion is O2-. You'll get used to this. Formula, MgO. I'm going to shrink my pen down a bit. Let's do the same thing for the next few. So lithium bromide. Lithium is in group 1. Bromide is in group 7, so 1-. So it becomes, metal always goes first, Lr, Li, Br. Next, a bit more tricky. Calcium is in group 2. Nitrogen is in group 5, so it's a 3-. Now we're going to get our little X factor trick, and we can get Ca3N2. Next, aluminium sulfide. Aluminium is the cation. Positive, cats are positive. And then sulfide, same group as oxygen. 2-, sulfide. Yeah, nitride, by the way, there was nitride from last lesson. Yeah, 3-. Sulfide, -2. Yeah, it's nice to see it. You realize that you just have to underline them really to know where they are, as long as you got the numbers running across the top. And then cross them down again, and we get aluminium 2s3, aluminium sulfide, and then potassium iodide, nice and easy. K+, I- goes to Ki. I like it. Okay. The next thing is naming. I thought it was a nice opportunity for us to do some naming, just to remind you guys of it. I know you did it a little bit in year 9, but I just want to kind of review it. So whenever you do a naming, the rules of naming, yeah, rule number 1, metal comes first. Metal goes first. Next rule, number 2, metal name never, notice I've capitalized it, never changes. Yeah. Number 3, the non-metal always changes. Always changes. Yeah. And it's either to 2 people, either an ide if it's on its own, or an 8 if it's with oxygen. So in this case, we're going to have magnesium sulfide. Notice it's spelled with an F, by the way. That is correct. pH is an ancient English misspelling, and it's no longer applied. So it's spelled with an F. And then we get potassium bromide. Then you get barium nitride. I haven't spelled that very well, have I? Barium nitride. If you're wondering if you need to capitalize the second word, you don't actually. Aluminium oxide. Aluminium, the metal never changes. Oxide. And then sodium iodide. Okay, and these are all simple ionic formula names. So what I thought I'd then do is I thought I'd give you a bit of a task. So 10 questions, 10 marks, 1 for each one of them. Yeah, each one is worth 1 mark. So it's out of 10. What I'd like you now to do, folks, is pause the video, and I want you then to have a go at it. Now, once you've finished all 10, I know that this is going to put a big delay in the video, but that's all right. Yeah. You can then unpause the video and check your answers, forward it to the end so you can see if you get it right. Strontium chloride, strontium group 2 +2, chloride group 7 1 minus. So Sr2 plus, Cl minus, looks like an A, Cl minus, final answer, SrCl2, 1 mark. Right, sodium sulfide, Na plus, S2 minus, cross and down, Na(2), subscript 2, S. Radium, oh blimey, radium, last one in group 2. So Ra2 plus and Br1 minus, cross and down, RaBr2. Nearly missed it. Next, magnesium sulfide, Mg2 plus, S2 minus, they cancel out, MgS. Next, aluminium nitride again, Al3 plus, N3 minus, cancels out, it's Alan. It's nice to reinforce stuff like that. So 1 mark for each of the final answers. Tick, 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 and tick. Tell me how many you got out of 5. That'd be great. So task number 2 is naming. So this one now, the metal is strontium. You just find them on the periodic table in reality. You never change the metal. It always goes first. But the non-metal, in this case, is going to become an ide because they're on their own. Yeah, they only ever change to an 8 when there's oxygen as well. So in this case, strontium fluoride. Next one, lithium sulfide. Keep doing that. Lithium sulfide, then radium chloride. Radium chloride, and then calcium oxide. Calcium oxide, and then aluminium. This is a tricky one. It's the only really hard one in it. Aluminium phosphide. And that one is spelt with a PH, which is weird. Phosphide. Sorry about that. My tablet's having issues over on that side. I think I've managed to get a little bit of water underneath my little screen protector. Phosphide. There you go. So it doesn't like it very much. Out of 10, how many did you get right out of my 10? Please note, no transition metals anywhere. So no Roman numerals were needed at all. Okay, so I've got 10 minutes to teach my lesson. Okay, complex ions. Right, guys, and I hate to say this, you just have to learn them. You have no choice. Just learn them. Yeah? So, here are your complex ions that you need for GCSE. And you just have, you can't make these up. You've just got to have them in your memory banks. So, I often teach this through a process called NOx. Nitrate. The nitrate ion is NO3, 1 minus. Just got to know that, folks. The hydroxide ion. Hydroxide ion. OH, 1 minus. Carbonate. Carbonate ion. CO3, 2 minus. I got all 10. Well done, Zina, you star. Last one, sulfate. It's not the last one, by the way. Sorry. Sulfate ion. Last one for NOx. SO4, 2 minus. Okay. Get in there. Next one, phosphate. Phosphate ion. PO4, 3 minus. Okay. So those are all the negative ones that you need. Just to point out, actually, there are others, just to tell you, keep you in the loop. There's also the hydrogen carbonate ion and the hydrogen sulfate ion. But I don't teach these to you guys because you can build them. can also have the hydrogen phosphate as well. You can build it. And the reason why you can build these ions is because hydrogen is always +1. And if you add to it a CO3 2-, when these guys come together, you form HCO3 and one of the charges is gone. Yeah, so you can build these two. These are called the hydrogen carbonates. You can add those to your notes if you wish. I'm going to have you building them more often than not. Okay, next one. And notice my change in color. That's because these are all the anions. Yeah, these are all of our lovely complex anions. A negative ion. Yeah, now we get our cations. So our cations, we're doing red. NH4. Oh, I probably ought to name it first. Owen, Lauren, outstanding. Well done, young lady. That's outstanding progress. Well done, Callista. Great score. Well done, Owen. So the first one we have is ammonium. Now I need to make very, very clear of this. Ammonium is NH4 + 1. Yeah, just a reminder, NH3 is ammonia. They are not the same thing. Ammonia is a gas. Ammonium is an ion in a salt. Yeah, it is not the same thing. Please be careful. So ammonium, now we get some oddities. Silver. You've got to know this, folks. Ag + 1. Next, lead. Lead is Pb2+. And mercury is Hg2+. You can also add zinc to that if you like. Zinc is always 2+ as well. It's quite nice that I don't mind zinc being on the list. I don't often include it, to be fair. Yeah, but those, and what you realize is there's only really one complex positive ion, one complex positive cation, which is a true complex, is that one. It's nice to talk about it. Technically, these aren't complex. Technically, but you need to learn them. I need you guys to learn. I need you to learn them all. Yeah, next lesson, I'm going to be asking you at the start of the lesson to make sure that you guys have learned your ions. You need to learn these. Put them in a poster if you want to. Do whatever you like. But they need to be absolutely bolted down. When we come into lesson from now on, I'm going to ask everyone in the class for a formula and charge of an ion. So we'll come into lesson and I'll go, Zina, ammonium, and she'll say to me, NH4 1+. And I will say, Masaru, hydroxide, OH-. And I'll then say, Ian, carbonate, CO3 2-. Yeah, does that make sense? Yeah, I need to make sure that these are really, really, really bolted down. Yeah. That's the complex cation, technically. Yeah, the others are technically simple, but you've just got to learn them. Learn this. Cannot tell you how important this is to the whole of the rest of your chemistry careers. Just ask my year 12s. Right, now we need to use them. So we know our ions. Tick, tick. We need to create complex ionic formulae. Okay, I'll show you how this gets a little bit tricky. So what we're going to do is I'm going to do some questions and we will do one together. And so I'll do one and then I'll put one on the chat. I know I've only got 5 minutes left. So question number 1. Let's go for sodium carbonate. Right, let's build it. So the first thing we do is cation, because the cation always goes first because it's the metal. This is Na+, because it comes from group 1. The anion, this is the problem. The anion is a complex ion I cannot get from the periodic table. I have to know its formulae. If I haven't learnt it, I can't do it. And then cross and down, and I will get the final form would be Na2CO3, sodium carbonate. Does everyone follow? Gonna do one more. Question number 2. Notice the difference. Let's go for calcium hydroxide. If you want to have a go at this, pause it, but this is a hard one, folks. Yeah, if you want to pause it, you can do. Cation, Ca+2, comes from the table on the period, comes from the group in the periodic table. Anion, OH-. Now, here's the problem. This entire thing is 1-. So what that means is I'm going to need to do my clever cross and down, but there's something awkward that now appears, because if I do this, the problem is I haven't multiplied all of this by 2. I've only multiplied the H. So what I need to do is add a bracket. It's what makes complex ions a little bit more tricky. I know I'm teaching you a language here, folks. I get it. Right, I had to use a bracket because I needed 2 of this entire. If you're going to look at it from a diagram perspective, that there is the calcium 2+ ion. Here is an OH1- ion. And this is going to stick to, this one is going to stick to the calcium, yeah, via the electrostatic attraction. But the whole thing will still have a charge of +1. So it's going to attract another one. Yeah, so another OH- is going to appear, and that's going to go. I'm going to flip it around just because otherwise I don't like it. But there you go. The other one's going to stick to it. So I need 2 of the entire thing. Hence why I need a bracket. Callista, outstanding. However, you need to do me a favor. Switch the O and the H around. You've just got to remember that, I'm afraid. And again, I am teaching you a language here, folks. I get it. Right, question number 3. Guys, you're doing great. We've got 2 minutes. Question number 3. Let's go for ammonium sulfate. Right, this is 2 complex ions. So I now have NH4 1+ and SO4 2-. And now I'm going to need 2 pluses to cancel out the 2 minuses. Cross and down. Yeah, the positive ion goes first, and it needs a bracket because I needed 2 of the whole thing. SO4. I know this is tricky, guys. Yay, typo. Cool. So I know this is tricky, everybody. Now, can I just point out, there are more complex ions than I've actually given you. There's also you're going to have the hyperchlorate ion, the hypochlorate ion, hyper and hypo. You can also have the acetate ion as well. Like, there's loads of ions, and the homework that I'm about to set you has got a couple of ions there which are above GCSE. But I'd like you to do a bit of research and find out a little bit about them and have a go at the questions anyway. I think it has really good value. So this method is how I'd like you to do this, folks. And anyway, this brings me to the end of my lesson. Look at that, 1 minute to go. We have finished all of my learning objectives. We have learned our complex ions. We have created complex formulae. Now I just need you to apply it, and I will be very happy. Right, let's bring my camera back online. There we go. And then I can start camera. Should be bringing back straight back to there. There we go. Bring it back to there. Right, guys. I will leave you guys be. I hope you found it useful. I'll post the homework on the Google Classroom in a few moments, and you can have a go.